Okay friends, welcome to part 2 of our video presentation on chapter 5 that deals with enterprise systems. In this part of our video presentation we'll talk about some of the common types or categories of enterprise systems that are currently being used by organizations worldwide. Now the first type of enterprise systems that we'll discuss are the so-called transactional processing systems, or TPS. Now thousands, sometimes millions of transactions critical to business operations are processed each day in large organizations. And those transactions can be related to sales, bills for sales and customer payments, inventory shipped and received, payments to employees and so forth. So literally some organizations process millions of transactions per day. Now, typical outputs of those transactions are low-level or simple reports involving invoices, checks, orders, or slightly more sophisticated reports. Let's say, weekly orders or summary of orders for a particular item. But typically, when we say transactional processing systems, or TPS, we are talking about systems that process, routine, low-level transactions that are done at a high volume. And the kind of systems that generate only simple low-level reports based on those granular transactions. Now, one example of a transaction processing system is the so-called payroll system. So the system that has the ultimate goal of paying employees every month or bi-weekly, depending on the kind of HR setup an organization has. Now, a transaction processing system does not mean a simple system, because handling payroll can involve a number of steps or high-level processes. For example, adding or deleting employees to the payroll, capturing hours worked, changing wage rates and salaries, and calculating, the paycheck amount, processing information in relation to W-2 forms. So a transaction system such as payroll system may involve a number of important and complicated sub-processes. So because of that, a transaction processing system can rely on a number of databases or subsystems. Perhaps an even better example of a transaction processing system that is quite complicated are transactional systems that help organizations to process sales orders. Because processing an order from a customer may involve dealing with a number of data sources. For example, a database related to customers, to sales data, to prices for products, to inventory data, because in order to process somebody's order, you need to know whether you actually have a particular item in stock, back orders, purchase orders, and so forth. So a transaction system processing orders from customers can be quite complicated. It can involve managing a number of databases, and also it can be a source of very important reports sometimes. Reports related to credit, to invoices, to sales trends, to exceptions, and other important reports. So transactional system, although it deals with this basic low-level operational data, does not mean a simple system. Sometimes those transactional processing systems are quite complicated. Now, another main type of enterprise systems are the so-called enterprise resource planning systems, or ERPs. I would say that nowadays this is the most common type or category of enterprise-wide or organizational information system. An enterprise resource planning system, or ERP, contains a set of integrated business applications or modules that carry out common business functions. So, for example, an ERP system may involve modules that automate marketing, HR, accounting, finance, production, and so forth, meaning each module covers a particular functional area within an organization. And the key idea behind enterprise system is that transactional data that is collected in one function, let's say in sales, is accessible to employees in other functions as well. For example, accounting, so that sales are properly being accounted. Overall, like anything that happens in one part of the enterprise, is made available in other parts of the enterprise as well. So there is that idea that enterprise resource planning system can be used to integrate data processing across different functions of an organization and across different levels of the organization. Again, I told you that one of the first research projects that I was involved in was PeopleSoft implementation at the University of Houston. And I told you before that PeopleSoft is that large ERP system that is used by universities to pretty much automate everything related to their operations. And I told you that University of Houston, they started small. They started by implementing finance module first. I think then they went to HR module. But eventually all transactions were automated with the help of that PeopleSoft ERP system, which meant that no matter who you are, I mean, you can be a student, you can be a contractor working with the university, you can be an employee of the university. Everything that you do is done through PeopleSoft. And sometimes it was like scary because, let's say as a student, I go to a library and I check out books just by scanning them at the checkout station, right? Once I check out those books, the information that there are books that I owe to the library is added to my student profile page in PeopleSoft. And then, there's a late fee charge, let's say $2 per day for every book that is overdue. So whenever the book is overdue, the system automatically calculates your fines and adds that fine to your student financials account. Then, if you're also an employee of the university, and I was an employee because, I was a doctoral student, so I was working part-time for my department. So your student account is also balanced with the employee account. In other words, you have like both views, like what you're getting from the university and what you owe to the university. And there was the connection between those two accounts because my employment made me eligible for some, scholarship or tuition discount. So it was all integrated, and it was scary because if something happens in one part of the system or in one area of your interaction with the university, it becomes, it creates like this ripple effect. And that kind of backfired on me once because once by accident, I mean, it's a long story, I don't want to tell you all the details, but what basically happened by accident, unintentionally, I was terminated by the system. In other words, HR kind of made that transaction that I was terminated from my employment position. Now that created a tremendous ripple effect. For example, because I was terminated in the HR module, I was no longer eligible for scholarship. I didn't have health insurance. All those things kind of accumulated and created like a big iceberg of problems for me. At that time. But once I fixed it, in HR, and it took me a long time. Eventually it kind of cascaded down to other areas as well. But it was a big mess. Enterprise resource system, they are based on a process-oriented view of a business. Basically, it's like as philosophers say, ontological assumption that any kind of organization can be conceptualized or can be analyzed as a collection of processes. And again, going back to my PeopleSoft implementation research project at the University of Houston, that's exactly what PeopleSoft consultants did at the early stages of PeopleSoft or ERP implementation at the University of Houston. They took University of Houston, meaning that one big organization, and they broke it down into hundreds and hundreds of processes. And I remember there was a manual, I think it had more than 1,000 pages, and this entire manual was basically a table where in the left column you have current process, in the right column you have PeopleSoft process. So basically they tried to kind of outline how every process will be changed or automated with the help of ERP system. Usually ERP, I would say not usually, but most of the time, almost always, ERP systems are purchased from a software vendor. So most companies, they don't create their own, they don't write code for their own ERP systems. They buy some kind of off-the-shelf solution. And ERPs were the first wave of enterprise packages, and you can probably tell that from that slightly archaic name, Enterprise Resource Planning. It just sounds a bit too formal and archaic. But nevertheless, it was the early form of enterprise systems. But later on, and we'll talk more about that in detail, organizations start creating specialized enterprise systems. For example, customer relationship management systems, or CRMs, or supply chain management systems. And as you can tell from the names, those are enterprise systems geared towards customer service. And this is those kind of enterprise systems are widely used by service-oriented or customer-oriented organizations. And then supply chain management systems, as you can tell from the name, are for organizations that are supply chain driven. So typically those are production companies or companies involving any kind of movement of physical goods or materials. Now this is how an enterprise resource planning system architecture looks like. You have all those modules that that automate value chain activities. Value chain idea comes from Michael Porter. And value chain activities means like the important, essential activities or functions of an enterprise, the ones that create value for a customer. So, for example, materials, production, sales, right? And also, ERP system would include modules that automate or streamline supporting activities. Supporting activities means activities that don't create value for customers directly, but nevertheless, those are important enterprise functions or activities that support value chain activities. So, for example, something related to finance, accounting, or human resource. So that's like a very high-level conceptualization of an enterprise resource planning system, or ERP. Now, ERP software market is a very lucrative market. The undisputed market leader nowadays is SAP or SAP. It's an international company nowadays, but it has its roots in Germany. And if you have time, I suggest you read about SAP. They have a very dominant. Here I have a Wikipedia article about SAP. They have a very dominant position in the ERP market, and their software is just very expensive and very powerful, because you can use SAP to automate pretty much anything, any kind of organization. But SAP seems to be especially common among those the so-called brick and mortar companies, companies involving physical movement of goods and services. For example, I know that SAP is number one ERP when it for oil companies, for example. Oracle comes second, and there are like some competing products from Microsoft, and some other products. So they are country specific or function specific. But SAP seems to be the market leader. It's extremely sophisticated system. There are people who SAP consultants. They spend sometimes most of their career specializing in one particular module. And sometimes they say that even career is not enough to really master a particular module. So rarely you have SAP consultants specializing in more than one module. And those consultants, at least as of now, are typically very highly paid professionals. So here you have an overview of SAP Business Suite. It gives you like an overview of the kind of modules they typically have. Something related to HR, finance, operations. They have powerful analytics module, and sometimes today a lot of vendors, including SAP, they offer kind of add-on modules that go beyond that kind of enterprise resource planning. They go beyond this back office function, and they offer some customer or supplier facing applications. For example, CRM add-ons, supply chain management add-ons, or supply relationship management add-ons. But once again, typically, a company like SAP would provide all the modules you will possibly need to automate most, if not all, of your enterprise. Now, ERP systems, they have a number of benefits. They support cross-functional processes. I mean, if you think about it, it's very important for an organization to have collaboration between different departments. I mean, you don't want to be in a situation where marketing sells something that production or operations people cannot produce, or marketing people, salespeople are not aware of the current inventory levels that they have, and they keep selling cars without realizing that the orders cannot be delivered, right? So, and this is just like one example of importance of cross-functional collaboration. So ERP systems, they help to ensure that cross-functional collaboration. Also, ERP systems provide access to integrated data through a unified platform. I mean, there is that principle that data needs to be stored once in one central location. Otherwise, you'll have data duplicated in various locations, and it creates a number of problems. First of all, because data is duplicated, you simply have larger storage requirements that cost money to have data duplicated. But the most important problem is that once data is duplicated, then a number of errors are possible. For example, marketing people make change to customer data in their database. Production people, they don't have access to this updated information. So the question becomes, which information is correct? The one that is contained in the marketing department database, or the one that is stored by the production department? Also, ERP systems, they can support global transactions. In theory, you can connect pretty much anybody to your organization, even in a different country. So typically those ERP systems, they provide you with functionality to just translate the interface, so somebody operating in a different country can seamlessly, can easy, collaborate with your enterprise. Again, like ERP provide not only centralized data storage, but overall kind of centralized computing architecture, so you don't have to deal with different applications that come from different vendors that are written using different languages and use different communication protocols. You can just rely on one centralized architecture for your entire enterprise, or one single information system platform for your entire enterprise. Then, if that's the case, then software updates are easy. You don't have to deal with hundreds of different vendors, hundreds of different licenses, and sometimes, ERP systems, they provide that standard IT platform that ensures compliance with external regulatory requirements. Now, I remember when U of H implemented PeopleSoft, I remember I was talking to the cashier's office. Now, cashier's office was responsible for processing student tuition payments, right? And what I found out is that PeopleSoft implementation did not create much value for the cashier's office per se, because what happened was the system was much more complicated than their previous legacy system. They told me something like, before using their legacy system, a cashier had to go through one or two screens to record and process a payment from a student. Now with PeopleSoft, the cashier had to go through like 7 or 8 screens. Also, because the system was more complicated from a technology standpoint, they had to hire an additional IT person or 2 additional IT people to help them with processing student payments with the help of PeopleSoft. They also told me that they had to hire an additional accountant because the system just was more complicated when it comes to recording and processing transactions, and now cashiers needed like more help from accountants to explain to them how to handle certain transactions. So in a way, all those things made work more complicated for the cashier's office, but overall the cashier's office and especially top management, they were quite happy with the system because the system was built in a way that ensured compliance with the latest government regulations in relation to university finances. So compliance with government requirements is very important for any organization, but especially for a government organization because they're regulated, they're managed by the state government, I guess. So compliance was number one goal, not necessarily simplicity of operations or cutting costs. So ERP systems, they create value in this regard. They ensure compliance. They ensure standardization of organizational processes. Now, another component of enterprise information systems worth discussing are the so-called data warehouses. The establishment and maintenance of a large data storage facility containing data on all aspects of the enterprise is the most important goal of a data warehouse. So data warehouse is indeed like a warehouse of organizational data. But the main function is storage. I mean, it's not processing, but storage of data, and we will expand on that a bit later. Also, a warehouse provides users access to data, that they need for their own job, and also provides some kind of sometimes analytics functionality. So, in other words, if somebody needs to do any kind of analysis in his or her line of work, then data warehouses, they provide access to the necessary data. It's designed for data warehouses are designed for analysis of data, not efficient performance. So, in other words, it's not about real-time entry of processing of information. It's about storing information and giving this information to whoever needs it for analytics projects. And sometimes data warehouses, they can generate automatic periodic reports or subsets of data for use by individual employees or departments, and those are typically called data marts. So data marts can be periodically generated. For example, a data mart with sales data for the past month, and that data mart will be used by sales department, by marketing department, or by finance department to do some financial modeling or forecasting. So this is like a very simple, representation of architecture of a typical data warehouse. So you have all those operational databases where transactional data is recorded. Now, once it's recorded in those operational databases, it's processed, and the processing typically involves improving data quality, like removing missing values, correcting mistakes, maybe simplifying data. And this is where processing or warehouse construction software is used. So once the data is processed, it's being stored in the data warehouse. And there is a software for maintaining the data there. And then, there's warehouse access and analysis software that helps individual users or departments retrieve subsets of this huge data warehouse and analyze those subsets. And this is where managers or users actually get access or value from the data warehouse. So this is like a very high-level, rough idea as to how data warehouses work. Some characteristics of data warehouses. At the end of the day, data warehouses, they're subject-oriented, and the more precise term for those subjects are data marts. So data marts like a smaller subsets of data warehouses. So a data warehouse is where all organizational data is stored, but this entire data collection can be divided into data marts, let's say related to customers, to claims, to orders, and so forth. And then those data marts, they're used by appropriate, employees or organizational units that are interested in that particular subject. Data warehouses are integrated. All data is stored in one single integrated location using typically or desirably using one integrated single format. So data marts, that retrieve data about specific subject, they are not separate storage units. Basically, those are like subsets or views of the entire warehouse. Time dimension plays an important role in data warehouses because it's not real-time data. It's typically updated like every month, every week. So typically, time dimension is always stored so that people know that this customer data is from past month. It has been updated recently or was updated 2 weeks ago, so time dimension is important. And also, data warehousing is non-volatile. Basically means that it's not for real-time processing of data. It's like a library. It's like archives. That's where you store data. And once you store it, anybody can read it, multiple times at high, at any kind of intervals. However, it's read-only. It's not updating in real time, because typically data warehouses are updated like in that kind of batch mode, like every month or something like that. Okay, now we're going to talk about customer relationship management systems or CRM. Now, outside of the IT domain, outside of the information system domain, customer relationship management is like a strategy. It's a strategy to make sure that the entire business is customer focused. So in other words, anything that a company does, anything from starting with R&D and production planning and ending with after-sales service and finances, is somehow geared towards serving customers. Now, if you think about it, this ideology, this view makes a lot of sense because ultimately CRM, ultimately any kind of organization is about serving customers. You could say that at a very basic level, any business involves giving something of value to a customer, and once you create value for a customer, the customer will give you money for that, right? So that's the essence of business. However, as I already explained, managing customer relationships involves a cross-functional approach. You cannot limit customer interaction to sales department, because sales department also needs to collaborate with production, with accounting, let's say for credit verification for a particular customer, with production to make sure production people actually understand what the customer wants. So CRM systems nowadays are basically like replacements of enterprise resource planning systems or ERPs, because service-oriented organizations, and typically here we're talking about information-based organizations such as university or consulting company. They're all driven by customer processes. So CRMs can be used as enterprise systems, automating an entire enterprise. And so we've been just talking about customer relationship management in general, right? But this is where customer relationship management systems, meaning information systems, come into play. They help organizations to compete using that CRM perspective that is IT driven. So basically, the idea behind CRM systems is that there's a single face to the customer, no matter which channel customer uses. So whenever a customer interacts with a particular aspect of a business, there's that single platform where everything is entered. So if somebody from another area of an organization kind of picks up a customer relationship, let's say you sell something to a customer, then the relationship is transferred to the after service department. But those employees in the after service department or tech support department, they will be able to retrieve all customer data from past interactions of the customer with the enterprise, with the entire organization. Another thing that drives CRM systems today, or maybe this is something that CRM systems are actually creating, is that CRM systems, their result or they're the cause of migration from traditional channels of targeting or dealing with customers such as call centers or field representatives or dealer network to electronic channels like email, websites, and communication using cell phones like wireless devices. So CRM systems are especially good when it comes to supporting or covering or automating interaction in those new electronic channels. Now, CRM systems, they come from a number of sources. First of all, you have CRM specific vendors, like for example, this graph explains it better. You have traditional CRM vendors such as Siebel. Now, Siebel was purchased by Oracle a while ago. So basically, there are vendors that offer CRM, standalone CRM suites. Now, some CRM systems are provided by ERP vendors. In other words, there is an ERP system that kind of automates those traditional back office functions, related to production operations, and then they would also add some kind of CRM add-on module so that you can also integrate those back office systems with the customer-facing interactions. Now, one thing that is gaining traction nowadays are web-based or cloud-based customer relationship management system, and I think the industry leader in this kind of architecture is Salesforce.com. I mean, if you ever have a chance, go to their website to explore the kind of products that they have. I misspelled it. So cloud architecture is really at the center of their product offerings. What they're telling you, they're saying, look, if you need a CRM system, there is no need to have your own IT infrastructure. What you can do, you can create an account for each of your sales reps, and they will be accessing that account using the web, using their browser. And there are using virtualization, like server virtualization. There are all those flexible and seamless plans. For example, if your organization is small, it has five employees, 5 sales rep, then you'll have a small monthly fee of, let's say, I don't know, $20 per month. If your organization grows, then there's no need to rebuild anything. You just can add additional users and additional modules, let's say related to analytics, for an additional fee per month. So it's very convenient. Everything is outsourced. Everything is done on the side of Salesforce. You as an organization, you don't have to worry much about your IT infrastructure. So Salesforce is getting traction, and I think overall there is that shift in fashion from client-server-based architecture to cloud-based, meaning from the internet. So I think we'll see in the next few years companies like Salesforce getting more and more market share in the CRM market. Okay, so this concludes part 2 of our video presentation on enterprise systems. We are done kind of discussing some of the most common types or categories of enterprise systems. In the next part, we'll talk about kind of less important, less strategic types of enterprise systems. So thank you for listening.